the source and the load. Remember, there in this circuit there are two components of it. This is the source right here, and this is the load right here, right? Those can be modeled by a lumped parameter circuit. So what we refer to it is as a lumped parameter circuit. The value of the ZL, that will permit maximum power transfer. I actually did a video on it. I'll leave the link in the description to in more detail what exactly is maximum power transfer. But what it is, the maximum power, this could be a load, this could be a motor, fan, or whatever. The maximum power delivered to this load is only going to be delivered when the load value here matches to that of the total resistance of the source network, right? Which is basically there are two components: resistor 600 ohm and inductor 50 micro-ohm. So remember this, and this is very important. Whenever you are trying to provide maximum power, that can only be achieved when ZL is a conjugate match for the Z source. The two impedance matches. So the first thing we are going to do is to find out the impedance for the source, which is simply just going to be, since the two are in series, so we just simply add them, R plus XL, and XL can further be expanded and written as J omega L. So if I plug in the values, R being 600, right, plus J omega is simply just 2 pi f, so 2 dot pi. The frequency here is given 1 megahertz, so 1 times 10 to the power 6 2 pi f, and L is simply 50 micro Henry, right? So if I take the product of this whole thing, my equation simply just becomes 600 minus J314, correct? Now, what is going to be the optimum Z load? What is going to be the optimum Z load here? Remember, goal is to have a conjugate match for Z source, right? So therefore, optimum load is simply going to be 600 minus J. Oh, by the way, this is going to be plus here because I had a plus sign over here. And here we're going to have a negative sign here. Why? So when we add the two, they cancel out, right? Therefore, the optimum Z load is going to be 600 minus J314. If this was negative, then this would be plus. Okay, so remember that maximum power is transferred only when ZL is a conjugate match for Z source. So, and this negative sign here basically indicates, reactance of Z load. The reactance of Z load is capacitive in nature, right? And what's the formula for the capacitive reactance? Well, Xc equals to 1 over 2 pi FCL. Our goal is to find out the value of the capacitor, CL. So CL, from this equation I can derive CL equals to 1 over 2 pi F dot XC. Let's plug in the values now. 1 over 2 pi dot 1 megahertz, right? 1 times 10 to the power 6, and XL is just going to be simply 314, and if you do the math here, 1 over 2 pi times 1 to the power 10 to the power 6 times 314, you will get 507 picofarad. So what does that mean? The value of ZL that will permit maximum power transfer from source to the load. Well, we need a 600 ohm resistor value over here, and then we need a capacitor in series. The value of the capacitor will be 507 picofarad. If we take a 600 ohm resistor and in series we have a capacitor value 507 picofarad. The two impedance will be a match, and that's what this problem was asking.